Hello and welcome to the penultimate video into the world of circle geometry for Extension 1 Mathematics. In this video we look at the tangents and secants and the relationship between the two and a circle. The theorem we will look at today says that the square of the length of the tangent from an external point is equal to the product of the intercepts of the secant passing through this point. It's very wordy, so let me break it down for you. We're going to say that the square of the length of the tangent from an external point, so the length of the tangent TA squared, is equal to the product, so we're going to multiply something, of the intercepts of the secant. A secant is a line passing through a circle at 2 points from an external point. In this case, the blue line TA squared is equal to the green line TB times the combined green and orange line TC. Let's see how we can prove this. We want to prove that TA squared equals TB times TC. We know that TA is a tangent to the circle and that TBC is a secant drawn from T to intersect the circle at B and C. We're going to join AB and AC to create two triangles, but they aren't in the same orientation, so I'm going to redraw triangle TBA so that it is in the same orientation as TCA. So in our proof, we're going to use similarity. So we start with, in triangle TAB and triangle TCA, angle TAB is equal to angle TCA. And we can say this because of angles in an alternate segment. We can also say that angle ATB is equal to angle CTA because they are common. They are the same angle in both triangles. Therefore, triangle TAB is similar to triangle TCA because they are equiangular. This means that TA over TC equals TB over TA because corresponding sides are proportional in similar triangles. Now, if we do a little bit of cross multiplying, we can see that TA times TA is TA squared and TB times TC is what we wanted to prove. Let's look at an example that uses this theorem. Example 20 says that TE is a tangent to the circle with center O. TAB and TCD are secants from T that intersect the circle at AB and CD respectively. If TA is 6 cm, AB is 2 cm, and TC is 3 cm, find the lengths of those lines TB, TC, CD, and TD. Pause the video to give yourself a chance to draw the picture and try the solution for yourself. Try labeling the diagram with the information given in the question. Okay, first up I'm going to label the lengths given to me in the question. Question A wants us to find TB, so I will highlight the line. It's easy to see with the labeling I've done that TB is 6 plus 2, which is 8 centimeters. Next, question B wants us to find TE. I know that TE squared is TA times TB. So TE squared is 6 times 8. Remember, TA is 6, but TB is the length of what we found in question A. This means that TE is root 48, or simplifies to 4 root 3 centimeters. Question C wants the length of CD. So I'm going to use the property that TE squared will also equal TC times TD. Now we don't know what TD is, but we can say that it's 3 plus CD. So 48, which is TE squared, equals 3 times 3 plus CD. Dividing both sides by 3, I get 16 equals 3 plus CD. So CD equals 13 centimeters. Finally, we want to find TD. This is just simply 3 plus CD, which we just worked out was 13 centimeters. So TD is 16. Example 21 says, in triangle ABC, points E and F are on the sides of the triangle so that BE is perpendicular to AC and CF is perpendicular to AB. BE and CF intersect at G. We need to prove that EG times GB equals FG times GC, and we also need to prove that AF times AB equals AE times AC. That's a mouthful. What I'd like you to do is take the time to pause the video and try and draw the picture for yourself. Try to think why it might be important that AB is perpendicular to CF and that AC is perpendicular to BE. Okay. Firstly, angle BFC, which is 90 degrees, is going to be equal to angle BEC, which is also 90 degrees. This is because BE is perpendicular to AC and CF is perpendicular to AB. What this means is that we've shown that two angles are equal to each other that are subtended by the same chord BC. This means that B, F, E, and C are concyclic points, so we can draw a circle through them. This also means that BE and CF are chords in a circle that intersect at G. And from the theorem that we learnt last time, EG times GB is going to equal FG times GC because they are the product of the intercepts of intersecting chords. For part B, I'll need to draw in a tangent AP from the external point A. I've done this because it means that AP squared is going to be AF times AB because the square on the tangent is equal to the product of the intercepts. Similarly, AP squared is AE times AC. Therefore, we've proved that AF times AB is equal to AE times AC because they are equal to AP squared. The last video in this series deals with circles which touch and the properties that are associated with them. Thanks for watching.